Mobility means it is the ability of the electron to move when the electric field is applied across the ends of a conductor. So, if we have a certain length of conductor, then it is going to move with a certain velocity which we had called as drift velocity. Now, when we have that drift velocity, it is going to be dependent on the electric field, because we had the equation for drift velocity as Vd equals minus E tau divided by m. This was the equation for the drift velocity, and from this I can say drift velocity is going to be proportional to the electric field. Now, if the field is more or the field is strong, in that case the drift velocity will be more. If the field is weak, then in that case we are going to have that drift velocity as a lesser value. If I want to remove that proportionality, what I have to do is I have to add a constant, and that constant, if I write it in the form of equation, I will get a mu and E, and this mu itself is called as mobility. So, what this constant is called? It is the mobility. Mobility is the ability of the electron to acquire the drift velocity when an electric field is applied. If I want to rearrange this equation to find the mobility, I will write it as mu equal to Vd divided by E, and this itself gives the definition of mobility. It is the ratio of the drift velocity acquired by the electrons over a unit electric field or per unit electric field. So, when the electric field is going to be applied, the electrons are going to acquire the drift velocity, and how much drift velocity they will acquire over that duration of time, over that electric field, that ratio will be called as mobility. And from this relationship itself, what we have is Vd is equal to mu times of E, or from that equation Vd equals minus E times E, or I can take tau inside and I can keep E outside, and divided by m. And when we take this Vd, it is usually taken with a mod, because we are not interested in what polarity our charge carriers have. The same thing is true for the positive charge, the same thing is true for the electron, which is the negative charge. So, we are not interested in what polarity that charge carries, we are interested in how much velocity it has acquired. So, if we have that value, then from this equation, if I compare these two equations and if I take the mod of this thing, I can drop that negative sign. Mu is equal to E tau divided by m. So, what I can say here is the mobility is equal to, or it is proportional to, the relaxation time. If the electron has got more time of travel between two successive collisions, then mobility will be more, and if the electron gets lesser amount of time between two successive collisions, in that case the mobility of that electron will be less. Second thing, whether it is a scalar quantity or a vector quantity, just by observing this, drift velocity is a vector quantity, electric field is a vector quantity, and if two vector quantities are getting divided and we are not interested in what sign it belongs to or what kind of charge we have in that case, so this mobility, I can say it is a scalar quantity, it is not a vector quantity. Then the third thing, dimensional formula, we can derive the dimensional formula from this equation itself. What is E? E is the charge of electron, and for charge I can write it as AT, and then there is another T for the time, so I can write one more T. This is charge, this is time divided by mass. So, if I take everything to the numerator, it will be m power minus 1 A and T power 2. So, this will be the dimensional formula for mu, that is mobility. Then ultimately the SI unit, again that also can be derived from this equation itself. What is that? It is, I can write it from here or I can write it from here. Both ways it is going to work. I can take E is the charge, so I can write coulomb. T is the time, so I can write seconds, divided by mass is going to be measured as kg. So this is the one kind of a unit, or the more standard unit, it will be extracted from this equation itself. Vd is the drift velocity, so it will be meter per second, divided by electric field is volt per meter. So if I take this ratio in a proper way, then what I can write for this one is, I can take this m to the numerator, it is going to become m square divided by volt is there. I can take this seconds to the denominator, it can be written as meter square per volt second. So this is the more standard unit for the mobility of the electrons or mobility of any kind of charge.